Hello, today we are going to look at factoring of difference of squares and factoring perfect square trinomials. The first one we're going to look at is this factoring difference of squares. There's a little checklist here. It has to have only two terms. Each of those terms has to be separated by a subtraction, and then both terms have to be perfect squares. So 1, 4, 9, 16, 25, so on and so forth. The general form of this factoring with difference of squares is this a squared minus b squared is equal to a plus b parenthesis a minus b. So for this first example here, we're going to look at, first we have two terms. So we have our x squared and then our minus 16. It is a subtraction sign, right? So we've met that. And then both terms are a perfect square. So this really is a 1, right? Which is a perfect square. We don't type that 1, but it is a perfect square. One way you could write this is think of this as like x squared minus 4 squared. And that gets you what your a and your b are. So a would be our x, and b would be 4. And then we just plug it into that a plus b, a minus b. So this would really become then parenthesis x plus 4, parenthesis x minus 4. And that's all there is to it. You can check your answers by using a box. So if you multiply out both this x plus 4 and this x minus 4, you'd get x squared, 4x, negative 4x, and then negative 16. And then you can see that the 4x and the negative 4 would cancel out, leaving you with just this x squared minus 16, which is what we started with. So looking at it that way, if we look at our next example, we have this x squared minus 49. So our a is going to be x, and our b is going to be 7. And how I got 7, it's 7 squared is 49, or you could also think about it as like the square root of 49 is 7. Same thing with x, like the square root of x squared is just x. So you could think of it that way, or you could think about what number times itself equals 49. And once I have x and I have my 7, I'm just going to follow that x plus 7 and x minus 7. And that's your final answer. Looking at these bottom two here, same thing, we have two terms. So we have one term, two term. It's separate by a subtraction sign. And then I also have 9, which is a perfect square, and 25, which is a perfect square. So if I look at my a value, a is going to be 3x. Again, the square root of 9 is 3, and then square root of x is x. And then my b value is going to be 5, square root of 25. And then I'm going to write it as such. 3x plus 5 in one parenthesis, and then 3x minus 5 in the other parenthesis. So even if there's a number in front of the x long as a perfect square, we'll be okay. So our next one, we have 36 and 121. 36 is a perfect square. 121 is a perfect square. So we get 6x plus 11. And then 6x minus 11. And that's all there is for difference of squares. Pretty straightforward. Our next one is perfect square trinomials. These are a little bit more difficult. I put a little checklist. The same thing has to have 3 terms. The first term and the last term have to be perfect squares. So again, 1, 4, 9, 16, so on and so forth. That middle term, you gotta have to check this to be 2 times A times B. So A being the last term and B being, A being the first term, B being the last term. We'll do the exact same thing we did on the last one. There are 2 different ones depending on if it's a plus or a minus. Right, so we have a plus here or a minus here. And that depends on if they're both minus or both additions. So if we look at this first example here, I'm looking at my first term, x squared. I'm looking at my last term, 16. Both of these are indeed perfect squares, right? This is a 1. So my A is going to be x, and my B is going to be 4. And again, this is just coming from the square root of x squared and the square root of 16. And then now I have to check, does that middle term equal 2 times AB? So if I take 2 times 4 times x, is that going to equal my middle term here? So 2 times 4 is 8, so this is going to equal my 8x. So then I know that this is a perfect square trinomial. The other thing I have to look for, the last thing, is this sign in front of that middle term. It's a plus sign. So my answer is going to be parenthesis this x plus my b, 4, and then that parenthesis squared. Right? It's 2 copies of that a plus b, and we would just write it as parenthesis squared. Looking at our next one, again, looking at first term x squared, last term 25. These are both perfect squares. So I can take the square root of them. I get a is going to be x again, and b is going to be a square root of 25, which is 5. 2 times ab does equal 10, so I'm good there. So now I have to see what kind of sign is in front of that x, that second term. And it's a minus sign. So my answer is going to be parenthesis x minus 5, parenthesis squared. Now our last two, we have our first term, last term. First term perfect square, last term perfect square. And I'll kind of do both of these at the same time. So I'm going to figure out what my a and my b would be. So a in this case is going to be 3x, and how I get that would just be the square root of 9, 3. And then b is going to be 5. And then I'm going to check 3 times 5 times 2, or twice AB. So 2 times 5 is 10, 10 times 3 is 30, so that does check off. So then now I can just write it as my A, 3x. My sign for that middle term is a plus. So it's going to be plus, and then I'm going to get 5. And then parenthesis squared. Same thing for this last one. Our A is going to be 2x. I'm sorry, I should have write that better. Whoops. So our a is going to be 2x. Our b will be 8. And I'll just write it as 2x minus 8 parentheses squared. Again, it's minus because of the minus sign right there. It's always the same sign as that middle. So that's the end of factoring with perfect square trinomials and factoring difference of squares.